Alright, there are trigonometric functions that you need to know from memory, and there are trigonometric functions that you would be allowed to use a calculator for. And so far you have the two special triangles, and now you have the unit circle with the four ordered pairs to help you generate the trig functions of the special angles, the 30, 45, and 60 degrees, and then the quadrant angles, the 0, 90, 180, 270, and any multiple of those. But here's another little, we call it a trick, and this was given to me by a student when I first started teaching, and it's extremely helpful, and it's just kind of a very cool pattern that occurs. And so we're going to start with the pattern, and I'm not going to fill in this top chart. This is what you're going to eventually remember, and I have lots of students, even my calculus students, will take this chart and write it down before they take a test so that they don't have to worry about remembering it later on. But the pattern, let's come down to this smaller table here. The pattern for the sine of 0, 30, 45, 60, and 90 degrees, or the radian equivalent, is going to be the square root of 0 over 2, the square root of 1 over 2, the square root of 2 over 2, the square root of 3 over 2, and the square root of 4 over 2. It's just a very cool pattern. By the way, all of these angles you could get either by using the triangles, or the 0 and the 90 you could get using the ordered pairs, but this is kind of a quick way. Now the square root of 0 over 2 is 0, so let's come up to the bigger table up here and just fill in the simplified. The sine of 30 degrees is the square root of 1 over 2, which is really 1/2. Square root of 1 is 1. The square root of 2 over 2 is simplified. The square root of 3 over 2 is also already simplified. And then the square root of 4 over 2 would be 2 over 2, which is 1. So now, using the idea of cofunction identities, the cosine of 0, 30, 45, 60, and 90, to find these we just reverse the order, because the sine of 90 degrees is the same thing as the cosine of 0. So we literally are just going to reverse the order of the first row. Right? And double check and see that this makes sense. We've got the sine of 0 equals the cosine of 90. The sine of 30 equals the cosine of 60. Remember, those angles add up to 90. They are co-functions. And then we have the sine of 45 equals a cosine of 45. Now to find the tangent, you would just take the sine over the cosine. And so 0 over 1 is 0. 1/2 over the square root of 3 over 2. Remember the shortcut, you have to multiply by the reciprocal, but the 2's would cancel. So it would be 1 over the square root of 3, or the square root of 3 over 3. Anything over itself is equal to 1. The square root of 3 over 2 over 1/2. When you simplify that, you just get the square root of 3. And then 1 divided by 0 is undefined, UND, or you can use a 0 with a line through it. So this is a really nice way to help you kind of remember the trig functions of the special angles. Generally what students do is they just memorize that first row, and then you know the second row is just the change the order, and then the third row you can find by doing the sine over the cosine. And certainly you can find cosecants and secants and cotangents once you know the first three. So the next thing I want to look at in this video is the signs of the trigonometric functions. And so when we were in the first quadrant, we had said earlier that the trigonometric functions of acute angles are always positive. But when we start to go into the second and third and fourth quadrants, remember those ordered pairs are changing signs, the coordinates are changing signs, and so the trig functions are also going to change signs. So if we just draw an ordered pair in each quadrant, alright, so we know in the first quadrant all of the trigonometric functions are positive. So we're just going to write all. Now in the second quadrant, we want to figure out what the 6 trigonometric functions are. I'm going to focus on the first 3 because once you find the first 3, you know the sign of the reciprocal is going to be the same. All right, let's look at the second quadrant. We know that r is positive. R is always positive. It's considered the length of the radius as you rotate around the circle, that terminal side. So sine is equal to y over r, and so y is positive, and if the radius is positive, well, when you have a positive divided by a positive, you'd get a positive. The cosine is x over r, so that would be negative over a positive, which would be negative. The tangent is y over x, which would be positive over negative, which would also be negative. And so in the first quadrant, we have all of the trig functions are positive. In the second quadrant, the sine and its reciprocal are positive. Right? So what I'd like you to do is pause the video and do the same thing that I've done here. Find the signs, the SIGNs, using y over r, x over r, and y over x, using these ordered pairs here, and find the signs of the trig functions for those last 2 quadrants, and then start the video to check your answer. Okay, the sine is y over r, so it's negative over a positive, which is negative. The cosine is x over r, which is negative, divided by r, which is a positive, so that's going to be negative. The tangent is y over x, and so it's going to be a negative divided by negative, which is a positive. So in the third quadrant, tangent is positive, and also its reciprocal, cotan. Alright, let's look at the last quadrant. The sine, which is y over r, is going to be a negative over a positive, which will give you a negative. The cosine is x over r, which is a positive over a positive. The tangent is y over x, which would be negative over a positive, which would be negative. So in the fourth quadrant, the cosine is positive. There is a little mnemonic device that will help you remember what the signs of the trigonometric functions are in each quadrant. And that mnemonic device, I guess I wouldn't call it a mnemonic device, it's more just a table or a chart. And that is all students take calculus. And what that means, so this ASTC means that the sine and its reciprocal are positive in the second quadrant. The tangent and its reciprocal are positive in the third quadrant. The cosine and its reciprocal are positive in the fourth quadrant, and all are positive in the first. So let's use this information to look at example 3. It says find the quadrant that theta lies in if tangent is negative and cosine is positive. So what I like to do is I start by writing the all students take calculus, and I start with the tangent. So if in the first quadrant everything's positive, the second quadrant sine and its reciprocal are positive, everything else is negative. The third quadrant tan is positive and its reciprocal, everything else is negative. And in the fourth quadrant, cosine and its reciprocal are positive, everything else is negative. So I start with tan being negative. So since tangent is positive in the first and the third quadrants, I know that in order for tangent to be negative, I have to be in the second quadrant or the fourth. And then out of those 2 quadrants, in which one is the cosine positive? And that occurs right here. So for part A, in order for the tangent to be negative and the cosine to be positive, you have to be in quadrant 4. Okay, let's try part B. Same thing, I'm going to write down all students take calculus. Sine is negative, so Sine is negative in the third and the fourth quadrants because it's positive in the first and the second. And of those two quadrants, which one is the cosine negative? And that occurs right here. And so this would put you in the third quadrant. Alright, I'd like you to pause the video and try practice problem 3, and then start the video to check your work. Alright, we start with sine being greater than 0. Sine is positive in the second quadrant, everything's positive in the first, and of those two quadrants, the cosine is positive in the first. So this would be the first quadrant. Part B, the tan is positive in the first quadrant and the third, and the sine is negative in the third. So this would be the third quadrant.